I thought I'd start by providing a working definition of community science. Then I'll describe some of the characteristics of community science. I had a chance to look at some of the survey results so far and was able to see some of people's concerns about community science. So I wanted to address some of those concerns and maybe describe ways that individuals and institutions can support and advance community science. So, starting with the working definition of community science, the essence of it is collaboration. It's community and scientists working together. It's about authentic partnerships where both parties are equal contributors. And if there's a slight leaning, I would say the leaning is towards um, a nod towards community priorities. One of the characteristics that I think distinguishes community science from perhaps more typical kinds of scientific outreach and engagement is that it's really driven by community priorities. This is an example of a community science project in Montego Bay, Jamaica, that was driven by the community's interest in enhancing local agriculture and better using local food production. And the science was deployed in service of that larger priority. It is community science, so it does use scientific tools and processes. I think it's important to acknowledge that science is more than research. It includes synthesis, it includes scholarship, it includes education, it includes application. And so when we talk about science, we're talking about a broad suite of scientific tools and practices. It's also important, I think, to adhere to the standards of scientific integrity. So community science is about using science to answer community questions. It isn't about using science um, to prove a particular point of view. It needs to maintain the openness and the adherence to evidence-based standards that's characteristic of science. Um, Third important characteristic of community science is that it designs for impact. This is a picture from one of an early project we did in Denver, and it was around looking at the distribution of chemicals in groundwater and how those chemicals were outgassing. And the original design of the project was to be a map, essentially showing where outgassing was happening. And community members asked how that map would be useful. How would it help people mitigate pollution in their basements, especially people who might not have the resources financially to pay for new kinds of mitigation. And so, in addition to creating the map, there was work with city officials to expand a grant program so that homeowners could apply for grants to mitigate the results of pollution if they found it. That's a good example of what it means to design for impact. It isn't just about understanding, it's about enabling people to act on that understanding. Another important characteristic of community science is that it leverages community knowledge. One way to think about this is science is a contributor to solving a community challenge, but it isn't the sole contributor to solving community challenges. And it's just as important to reach into the reservoir of community capacity and community knowledge to solve these challenges. An example of this is this picture from a project in the Pamir Mountains of Afghanistan. And villagers in this region of the world use ecological calendars, calendars that are not driven by astronomical events, but are driven by ecological events, things like birds appearing, plants flowering, and they use those signals to guide their agricultural practice. The challenge that they were facing was they hadn't been able to use these calendars for several decades because of conflict and because of forced or mechanization of agriculture. And as they recovered these calendars, they no longer matched the conditions around them. The climate change had actually evolved the climate away from the conditions that the calendars were created for. So they wanted to work with climate scientists to update these calendars. And I think that kind of embedding of science in an older cultural tradition is an example of what it looks like to position science as a humble contributor to a larger set of processes. And building on that a little bit is community science responds to larger issues. It recognizes that the scientific or technical issue communities are facing is part of a whole host of larger issues. And an example of what this might look like um, is is from Hurricane Katrina. This is a snapshot of the Ninth Ward after the hurricane. And what it points out, at least for me, is that the technical sort of issue or the scientific issue of understanding hurricanes and hurricane vulnerability is intrinsically linked to larger societal issues, issues like systemic oppression, like racism, and you can't tackle one without the other. And so community science necessarily responds to these larger issues. I have a friend who says that if you're not designing to advance equity, you're designing to advance the status quo, which often means perpetuating existing inequity. That's the kind of consideration that has to be part of community science. I wanted to talk a little bit about what we learned in the survey. What we heard is that community science is sometimes difficult. Top 3 reasons community science is difficult for scientists. The first is difficulty that scientists have connecting, sorry, I think top 3 reasons community science is hard for scientists. One is the difficulty scientists have connecting to communities. They don't know where to start. They don't know which communities to engage with. They have a hard time sometimes engaging with those communities. The second reason and the third reason have to do with institutional support. Often scientists don't feel like they have the money or the time or the job appropriateness to engage in community science. Communities also reported, community leaders who took the survey also reported some difficulties. One of the biggest difficulties was the lack of local scale information. I consider this sort of a downscaling problem, right? It's challenging to take geoscience, which tends to deal with large scale, earth scale phenomena, and translate that into information that's usable at the scale of a city or a neighborhood or even a region. It's also expensive to work with scientists, and it can be difficult to find and communicate with scientists. So how do we address these kinds of constraints? I think it's a mixture of individual and institutional modes of addressing. So some of the individual things you can do as scientists or as community leaders really involve how you choose to work together and how you structure your work together. One of the things we've seen in the Thriving Earth Exchange is a sort of simple 3-step process can be really effective. For scientists, the 3 steps are listen, connect with a community leader, and don't offer advice about what they should do. Don't try to come in with a scientific agenda about what they need to pay attention to, but really try to put yourself in the shoes of the community leader and understand what their issues are, what their community aspires to be, how they plan to get there, and what are the challenges they face in getting there. It also means adopting a kind of asset-based approach. What are communities good at? What strengths do they bring to the table? And then as a scientist, you get to play a game that you could call 6 Degrees of Kevin Bacon or climate change or geoscience. How does what you just heard connect to earth science? Don't worry if it seems far out or crazy, just brainstorm as many connections as you can. And this is a place where you can invite the community member to be a participant in that brainstorming. And then finally, because time and money are real barriers to doing work, you can select of all those different brainstormed connections that you did, you can select the ones that you think are most doable, the ones that fit into your available time, that may be matched to capacity you have in your institution, or can engage students if you work with students. Think about your capacity. I have a friend who calls it what's in your closet. Think about what's in your closet and how does that connect? For community leaders, I think it's a very similar process. It's the mirror image of the process. So one of the things I think is important is initially for community leaders not to be too deferential to the scientific processes or to their scientific partners, but to be pretty vocal about articulating the priorities they have and the capacities they have. Then you can work together to explore the fit of earth sciences. And here it's important to ask questions and follow up and be somewhat critical about the connections. And then finally, select those projects after you've brainstormed these projects together. Select the ones that really maximize or take advantage of your strengths and help you address your priorities. And as we do these individual processes, I think we build more and more capacity and more examples of what it looks like to take large scale processes and see what they mean locally. And if we can collect and elevate those examples, we can start to overcome that barrier that was recognized earlier, which is the difference between institutional processes. And I just want to close with some of the things that AGU is doing to try to support this movement of community science. I think community science is blossoming. I think scientists want to be engaged in the world. They recognize the value of this. I think communities around the world are asking for scientists to be participants in solving and addressing local challenges. And for these reasons, I think it's exploding. AGU is doing some things to push that along. One of the things we're doing is matching. We're a large organization, so we can build partnerships with other organizations. And those partnerships can be used to help connect scientists and community leaders. One of the things we saw in the survey is it can be hard to connect. This addresses that. Second thing we can do is coach. In the survey, a couple of people pointed out that sometimes it's difficult to work across sort of science community lines because there's different vocabularies, there's different languages, there's even different value systems sometimes. We can start to coach each other through that and nurture each other through the process and start to learn the skills together to do this. And finally, because we're a large scientific organization, because we have some heft in the scientific community, we can elevate the importance of this work. We can lift it up, we can surface examples, and in doing that, I think we can put pressure on institutions to change things like the tenure policy and the promotion policy to promote this kind of work. So that's kind of what I wanted to say about community science. I think at this point, I'll pass it over to Natasha to provide a little more detail about what it looks like on a kind of on the ground level. Thanks, Natasha. And thank you, everyone.